All right, so today I was going to go over quiz 3 and talk about the final as well. We did this already, right? Or identical. So I don't need to cover this again, right?
No.
Unless you want me to. No, okay.
Number 2
Is lucky. Should I cover this one?
Yeah.
Yeah. All right, so bool is lucky. So we need to implement this function as lucky. And, you know, I'm sure it's a vector, it's a function. We're going to need to loop through the vector. So I know there's probably a for loop there. Implement a function that determines if the vector only contains the number 7. The function returns true if 7 is the only number that appears in the vector. Otherwise, it returns false. So for us to know that the only number that appears in the vector is 7, we need to look at every value. If we find a value that's not 7, right there on the spot, we return false. We return false. It's not lucky. If we come to the end of the loop and we didn't find anything but a 7, then we can return true. So I ranges from 0 to v size minus 1. And if we find something that's not a 7, then we can return false. We know it's not lucky. We have to have all 7s to have a lucky vector by definition. And I'm going to use that form right there. Any questions on that one? You see, it's just a matter of, you understand what the problem is asking. The English is not the problem. It's translating that into code, right? That's what you need to practice. You need to practice these problems without looking at your notes, because on the quiz, or the final in this case, you won't have access to your notes. Write test code that tests every statement in the isLucky function you implemented. So we're going to create minimal test code here. We're going to create a vector int, call it v. Let's push back a 7. And now we're going to assert that the function is lucky returns true for this particular v. And if we want to play it safe, I'll take that on the exam. But to play it safe, we might make something a little bigger. And then let's push back another number. Let's say the number 4. The number 4 is unlucky in China, I hear. Does anyone know? Can someone verify that? Anyone know that? So if we put a 4 in there, that means we're going to lose in the casino. So it should return false. All right. Do you see, we reached this statement in the first assertion. In the second assertion, we reached this statement. And all other pieces of code executed as well. So that's called an issue of coverage. So the test has a degree of coverage, at least that executes every piece of code in the function. So that was the requirement that I have. You know, it's not a comprehensive test. There's still edge cases to test. What happens if you pass in a vector with no values? Is that unlucky or is that lucky? No, and so on. Well, we're not going to get into that. I just want you to show me that you know how to use assert to formulate a test, and that you know how to execute every piece of code in the function. All right, how about this one? Is strictly increasing. Did we cover this?
Yeah.
Should I cover it again, or do you want to skip it? Skip it, right? Skip. All right. Are complements. Let's cover this one. I know we didn't do this one. I dreamed this one up for the quiz. All right. Here's the function. It's a predicate function. It returns true or false. We pass in the information. It tells us true or false. Are A and B complements? But you know, the problem defines what we mean by complement. The elements of the two vectors that are passed in must pairwise add to 0. Pairwise, right? So we look at A0 with B0 and A1 with B1. So we do pairwise addition of the elements from A and B. And here's the example. 2, 3, 0, minus 7. If you if you do pairwise addition of their elements, minus 2 plus 2 is 0. 3 plus minus 3 is 0. 0 plus 0 is 0. So minus 7 plus 7 is 0. That's pairwise addition. So this is an example of two vectors that are complements. If they have different numbers of elements, they are not comparable, so we return false. Yeah, so in addition to having values that add to 0, they have to be the same length as well. So that's this additional requirement here. If the two vectors have different numbers of elements, then they are not comparable. In that case, return false. So, you know, we're going to have a loop that looks at AI and adds it to AB and checks to see if that's 0, but that won't work if they have different lengths. So we need to check their lengths first. If A dot size is different than B dot size, then we're going to return false. They are not complements. Now, once we've gotten past that, let's check to see that they pairwise add to 0. I'm going to use A dot size. We could have used B dot size because we know we've just tested that they're the same length, that they have the same size. So if A of I plus B of I equals 0, then we're going to return, did it wrong. We want to see if they don't equal 0, right? If we find two that don't add to 0, then we know that they're not complements. If we check every pair and we don't find two that don't add to 0, then we can return true. They are complements. That was number 5. Any questions? Okay. Count occurrences. Did we do this? Should I do this? Yes. Okay. Count occurrences. So how many times does K appear in A? Is that it? The function returns the number of times K occurs in A. A is a two-dimensional array, and rows and columns are some constants. We don't need to define those. We just assume that they're defined for us in the context that we're writing this code. Up for so we have two indices to work with, you know, I and j or whatever you want to use. I and j is kind of common, so I'm using that. So we need to range across all the valid values for the indices I and j. And we will do something with each element that we see. That's how we address each element, like that. A, I, j. That's the ith row, j's column. That's that cell in the array, two-dimensional array. Count the occurrences. Oh, so we're going to compare that to k. We want to know if, for each ij that we look at, if it's k. If it's k, then we have this counter, and we'll increment the counter. That means we need to initialize the counter. We'll do that here. Make sure we set it to 0. In C++, we don't get default initialization to 0 like all other languages do. So we need to initialize that explicitly. And after we have that, we return count. Any questions on that? Search. Implement a function that searches for a given value in a vector of integers. If the value is found, the function returns the index of the value in the vector. Otherwise, it returns -1. Do not assume the values are in order. Do not use binary search. For example, and I give an example there. I think we did this, right? Do we want to do it again, or do you want to skip this? Skip. Huh? Skip? I'm hearing skip. All right. That's 7. Binary search. We don't need to do this again, do we? All right. That's it then. You have seen everything. You've seen everything that'll be on the final. You haven't seen everything that'll be in your future career. I shouldn't be so focused on the final exam. Students tend to be focused on their grades. And the instructors are focused on their learning. And it seems as if you don't, require work, that produces a grade. You don't see a lot of learning, but, I don't know, that's just how it works. So what do you want to talk about now? We have a lot of time left here. There's nothing new on the final. I mean, there's problems that are new. Some of the problems I've just copied from the quizzes and the assignments. But then other problems are new, but they resemble the problems that you've already solved. Yeah.
How many problems on final?
Let's see, like 20-ish, something like that. 16 maybe? I can't remember. 25, what's 25 times 16? That's 400, right? I think there's 16 problems. Yeah, 25 points each. This is the total score is 400. Is that how I did it? 400.
16 problems.
16, 25 each.
So those are like 5 problems per quiz on there? Or?
Something like that. You know, there's going to be at least one question about classes.
Oh,
Defining class, huh?
1 on sorting and then 5 on each of the quizzes.
Well, there's definitely going to be a question on sorting. Now, you know, there's many different ways of asking the sorting problem. Well, actually, there aren't. I can either have you sort in increasing order or decreasing order. I could ask you to sort a vector, or I could say sort an array. Those are the 2 variations I can think about. I don't know. I can't think of any other variations on that problem. Yeah.
Are you gonna, like, you know how on the second part of the last lab, that was like a sort function? Like we just said, my sort something.
Oh, here.
Oh, no, the second one.
Oh, the logarithm?
Yeah, like.
No, that will not be on the final.
Well, I'm thinking like there was like a kind of, oh, never mind, exercise 3.
Exercise 3?
Yeah, how you have the sort v begin, v end. Is that how you're gonna want it, or do you want the actual?
No, this will not. I'm not going to ask you to produce that. No, I'm going to write the algorithm out. I want you to write out the algorithm like this one. It'll look like this. I'll ask you to write an algorithm that sorts either a vector, an increasing or decreasing sequence, or an array, an increasing or decreasing sequence.
How do those change? Like how are the 3? How are those 3 different?
Minor differences, tiny little differences.
Is it possible?
And there's many ways of implementing sort, by the way. So, you know, what I recommend for you to have done, what I recommended that you in the past, was that you come up with your own sorting algorithm, struggle with the problem for half a day, and devise a process and test it. That was what the lab was about. Now, you could always skip that hard work and just look it up on the internet or your book and memorize it. You could do that. Now, that's not, and that'll get you through the class, but it won't be good for you professionally. It won't help you grow in your skill as a computer scientist or a software developer. Anything else? Binary search is going to be on there. That linear search, I think it might be on there. So binary search and sorting, those are 2 starting algorithms that everybody should know. So when you go into a job interview and they give you a piece of paper and they say, just sketch it out for me, the algorithm to do a binary search, how would you implement it? You can use any language you like or just use pseudocode. Just write down the algorithm for me. And then if you can't do it, you don't get the job. That's how it works. So I'm trying to get you ready for that eventuality. All right. Well, that may not be your question you get in the job interview, but it might be something like that. Like I was talking to a former student, and he's not a computer science student. He's a math major. He was a math major here. He graduated a little under a year ago, and he did a lot of work with me while he was here. He took a lot of my courses. And now he's looking for work. He doesn't want to be a teacher. He wants to be a software developer now. And I've been kind of working with him a little bit. And he's interviewing for jobs. So he's telling me about, oh yeah, this time they asked me the very question I told him to practice, which was to reverse a singly linked list. And he did okay on that. It looks like he's going to find work, which is good. But he has been practicing. He's been preparing for those tests that he gets in job interviews. And it looks very much like the kind of problems that you're working on in this class. A little bit harder, but not a lot harder. Because you can only come up with so much when you're in an interview and you're asked to work a problem out and they give you an hour to figure something out. That's not a lot of time. So it's going to be a simple problem. Anything else? Do you want me to review anything about classes or anything like that? We're really early. We don't need to go. We don't have to just keep going. We could quit. Yeah.
Will the questions be like questions we've seen on previous midterms or previous quizzes? Or
Some of the
similar?
problems are exactly the same, and some of the problems are variations of those. And there's one problem that pushes the boundary a little bit. It's not tough actually, but if you've approached the labs and the assignments correctly without trying to memorize code that was presented to you, and trying to solve problems with creative thinking, then you'll do okay on one of the problems that I'm asking. And it's simple. It's a very simple problem, but it may look different from the ones you've studied. That's just one problem. Yeah.
It's going to be a 2-hour block, right?
Yeah, 2 hours. Well, an hour and 50 minutes.
Will we have more questions?
Huh?
Will we have more questions than we normally do?
Yeah, 16.
16.
Yeah. And I expect that half of you will be finished in a half an hour. I mean, it's not a killer exam here. It's gonna be easy. It's an easy exam, super easy. Okay. All right. Anything else? So I don't mean it's super easy, because then you won't study. It's going to be super hard. It's a super hard exam. Make sure you study for it. All right, that's it then. All right. I'll be in lab today, so we'll have one last lab.